guess looks like we're ready to get started here. Hello, everyone. Welcome to this session about C++. My name is Augustin. I am here with Nick. We're both from the C++ team at Microsoft. We work on C++ developer tools, specifically Visual Studio, Visual Studio Code, and there's another tool called Vcpkg we'll be talking a little bit about if you haven't heard of it. So this session kind of has a focus on cross-platform development with C++. But we're not only going to be talking about cross-platform development, so we're also going to be talking about some other stuff. So whether or not you are interested in cross-platform development, you should hopefully find some value in this talk. So let's actually go ahead and get started here. So first things first, some announcements. They're not brand new announcements. Actually, this happened about a month ago. But Visual Studio 2019 is now available for general use. You can use it in a production environment. It's out of preview. So that's now available. There's lots of new features and performance improvements and so forth that the new release can bring for you. We will go into a lot of depth in what's new in Visual Studio 2019. We'll also be talking a little bit about the next update to Visual Studio 2019 because we're already pretty close to releasing it at this point. The third preview of it has actually come out. But first, if you are on an older version of Visual Studio, we always like to talk about the upgrade experience a little bit. We want to make that as pain-free for you as possible. So there's a few guarantees that we kind of provide for you here. So just as with Visual Studio 2017, you can install the latest IDE side by side with your current one. So you don't have to uninstall your old version and then switch to the new one, and then if for whatever reason you want to go back to the old one, you have to go back and reinstall. There's none of that to worry about. Visual Studio installations work side by side now. You can have any number of them. You can even have a preview version and a release version side by side. That will work just fine. So you can test out things until you're ready to kind of fully migrate. And then next, if you are stuck for whatever reason on a specific version of the MSVC compiler toolset, you can still use whatever your preferred version is with the Visual Studio 2019 IDE. You can actually install the Visual Studio 2017 and 2015 compilers in the Visual Studio 2019 installer. So you don't even have to have the old IDE installed for those. And if you use an even older version of the compiler than that, you can still have the old IDE installed, and then you can install the new one and target the older compiler if you prefer. In the long run, we do recommend upgrading to the latest tool set. You'll get a lot of benefit out of it, performance improvements, and new language features and stuff like that. So that's definitely worth knowing. But you don't have to immediately switch to the new version. So don't consider having to upgrade to the latest tool set as something to hold you back from upgrading to the newest IDE and getting the newest productivity features and cross-platform features and so on that the new IDE brings you. The other thing is binary compatibility. So if you have dependencies that are compiled with Visual Studio 2017 or Visual Studio 2015, that's OK. You can still have your application compiling with Visual Studio 2019, and they will work because they're binary compatible. So that's a guarantee we provided between 2017 and 2015, back when we announced VS 2017. And we're continuing to provide that for Visual Studio 2019. So you can continue to take advantage of that if you're upgrading. And the other thing is, so I talked a little bit, there's another tool our team works on called Vcpkg. It's a cross-platform library management tool. You get access to hundreds of open source libraries for C++, and you have full access to that catalog to help you kind of manage your dependencies as you upgrade and make sure that they're all compiling with the latest compiler once you are ready to migrate to that. And another thing I talked a little bit about was this idea of preview. So there's two channels kind of for Visual Studio. There's a preview channel and there's a release channel. You can actually, if you want to find out what's happening in the 16.1 update to Visual Studio 2019, so that's the next update after the general release, you can actually download a preview build to try that out, and you can try that out side by side, and that's a good way to access the latest features as soon as they're available. Preview builds are not really for production environments, but you can certainly try it out to see what's new and give us feedback or see if you're kind of excited about what's coming up. And there's actually quite a lot of functionality coming up in 16.1. So that's something worth trying if you get the chance. All right, so I said this session will focus a lot on cross-platform development. And by that, I'm really focusing on targeting both Windows and Linux. We also have iOS and Android targeting as well in Visual Studio. But this kind of talk will kind of focus on Windows and Linux specifically because Linux has been a big area of investment for us recently. The idea when we say cross-platform development with Visual Studio, basically what we're saying is you can have one IDE, you can have one kind of code base, one kind of project, if you will, that can target two different operating systems. So rather than you having to have a completely separate environment for targeting Linux and a completely separate environment for targeting Windows, you have one environment that can target both. And that's kind of the value proposition here. So to kind of get into that in more detail, let's actually jump into a demo. So I will switch to my machine here. Okay, it looks like it's up. All right, so what I have now, so I opened Visual Studio 2019. In Visual Studio 2019, this is kind of the first thing you'll see when you get started. I have kind of some options to get to my code on the right there, and on the left is my recent projects. I'm going to start fresh. I'm going to create a new project. So I'm going to go ahead and click Create a New Project. This will bring me to the New Project dialog in Visual Studio 2019. I have a nice search feature here. I will actually go ahead and search for CMake. And I'm actually going to create a CMake project, which is a special type of project from all the other Visual Studio projects you might be familiar with. So I'll go ahead and select that. Now, and I'll just go ahead and give it a name, something like, I don't know, WSL demo, because that's something we'll be talking about. And then I'll go ahead and create it. Now, the reason I created a CMake project is because I'm trying to do cross-platform development. I'm trying to target both Windows and Linux. Our recommendation for cross-platform development at this point is to use CMake. Visual Studio has native integration for CMake projects. So just as you have this support for MS Build projects and SLN files and VCX files and that kind of thing, you have that kind of experience as well for CMake using a CMake project system. Now, one thing you'll notice pretty quickly here, if I look at the left side here, in my Solution Explorer, I don't have a solution file. I don't have a Visual Studio project file. I am in open folder view, which basically allows me to use something else than MS Build. And since this happens to be a CMake project, everything will kind of just work out of the box. You can also bring your own build system if you'd like and configure it. So you can see here, instead of a VCX project file, I have a CMake list.txt file. And my code is here under WSL demo. And if I open it, by default, the template is just going to print hello CMake. I will go ahead and just change that to hello build, just to have something a little different. You can see by default I'm targeting x64 debug. This is for Windows. And so I'll just make sure. OK, so I make sure I have my target here selected. And I'll actually go ahead and run it just to make sure that everything works. So that's going to build my code locally and run it on Windows exactly as I would expect. And it says hello build. So OK, that works the way I thought it would work. But OK, let's say I wanted to actually also target Linux from the same project. Now you might think, well, how does that work? I'm on a Windows machine here, right? So how do I target Linux? Well, the way you would do it in Visual Studio 2017 is you would generally connect to a remote Linux machine. So there's something called the connection manager. If I use this search feature here at the top, which is really good to use, by the way, in general for finding stuff in the IDE, I can search for connection manager, and it will bring this up. And I can actually add a connection to a remote Linux machine. It'll set up an encrypted SSH connection, and it will actually sync files between my machine and the remote Linux machine. And that's a pretty nice experience, because then I can just work in the Visual Studio IDE on Windows. My code still builds on Linux. I can debug on Linux using GDB, and it just kind of works seamlessly using the Visual Studio UI. So that's kind of a nice experience just on its own. But there's an even easier way now to get started. You might be familiar with something called the Windows subsystem for Linux, which was announced a few years ago, I think. Essentially, what that lets you do is you can run a Linux shell inside on your Windows machine. I can actually go to the Microsoft Store, I can download Ubuntu, and then I get a Linux shell that I can interact with. So I actually went ahead and did that before getting set up here. And what I'm actually going to do here, I'm going to go to Manage Configurations. Okay? And what this is going to do is this is going to bring up what we call the CMake settings editor. So in the past, if you had a CMake project, you would kind of go into this CMake settings.json file, which is kind of the code behind, I guess, of this. So if I click out of JSON, actually, it'll show me this is essentially how I can configure my CMake project. But I can actually just do it straight from this editor instead. So I have a nice UI now to interact with it, kind of like how with MS Build projects you have the project property pages, so you don't have to go and hand edit the actual VCX project file and deal with a lot of XML. This is kind of the same experience here. So there's lots of different configurations here for the CMake project. I'm not going to really mess with them right now. What I'm going to do is I'm going to click this plus button, and I'm going to add a configuration. And there's quite a lot of configurations available. So you can see I have here Linux debug and release. This is if I'm targeting a remote Linux machine. I would go and set that up, and I would set up my SSH connection using the connection manager, and then I'm good to go. But we're going to use WSL. So we actually have some new templates here. If I scroll down, you can see WSL, debug and release. I'm going to go ahead and pick this one, WSL debug. And I'm going to select it. And then just to make sure that everything's good, I'm going to save and generate CMake cache to load variables. So CMake is going to do some generation behind the scenes here. And if I actually go to the CMake tab, I'll be able to see it. So let me just make sure it's doing that. There we go. Okay, so it's working on that. And essentially what this is doing is it's configuring my new target using the Windows subsystem for Linux, which is really just running on my local machine. So I don't have to go through all the trouble of, okay, I need to provision some other machine that I'm connecting to, and then I have to actually set up that connection and get that all working just for my development environment. I can do that just in WSL. And because I'm using WSL, I also don't need to sync files all the time between my machine and another machine and have to depend on my network connection being stable and running fast and that kind of thing. I can actually just do that locally. So it can run actually pretty fast by comparison. And it's just a really easy way to get started with targeting Linux. And yep, it's just going ahead and getting that set up right now. And essentially what I'm going to do once that's done, you can see here C++ IntelliSense information is refreshing. I'll actually go ahead and just to prove that it works, I will actually set a breakpoint around here. And it looks like CMake generation is finished. I'm going to go ahead and, so you can see here I'm on WSL debug now, so I'm now targeting Linux. I'm not targeting Windows, but I can also switch to my Windows target when I want to. And if I select this and I start debugging, this should build my code in WSL and then start up a debugging session using GDB behind the scenes. But I still get the Visual Studio experience of debugging, so that kind of UI. And you can see it actually paused here. So it actually hit the breakpoint. Everything is looking good. If I hit F10, you can see my Linux console window on the bottom right, hello build. So I successfully compiled and ran my code now in a Linux environment. And if I want to switch back to Windows now, I would just go here and switch back to x64 debug, and I can switch between them. Really easy way to get started, basically a few minutes. We're targeting both Windows and Linux using the CMake project template and the WSL support. So that's something that's kind of interesting to see. We'll go ahead and switch back to my slides here. Okay. All right, so some key takeaways. So as I said before, if you're doing cross-platform development, we recommend CMake. We have a great CMake experience in Visual Studio. It came in Visual Studio 2017 originally. We've continued investing in it over time, and it's just gotten better and better in Visual Studio 2019. So definitely try it out if you're interested in targeting both Windows and Linux, which of course you can do just from the Visual Studio IDE. The Windows subsystem for Linux integration is a great way to get started. You can always switch to using the connection manager and connecting to a remote machine later if you wish. But this is a really quick and dirty way to try things out, see how it works, see if you're happy with it, that kind of thing. And you can always set up that SSH connection later if you need to. Okay, so to kind of go a bit more in depth into Visual Studio 2019 and the features it has available, and there's quite a lot, we kind of broke down this talk into a series of steps. Consider this like a software development workflow, starting with from the point where you're first acquiring the tools you need for development to the point where, all right, so you can configure your environment to make sure everything works. You'll run an initial build to make sure that your configuration is actually correct and you can go ahead and actually start working on the project. You might write some code, you might do some debugging, you might test your code, you might analyze it to see if it's following the C++ core guidelines, or if it's like secure code and stuff like that. And at some point, you'll commit it to source control, and it's kind of a cycle that keeps going and going. Well, maybe not the acquiring tools part, and you might just do that once, but if you have to switch development machines, you might have to do that again at some point as well. So let's actually go through these steps. So if we start with acquiring tools, so as I said, Visual Studio 2019 is now available. In terms of acquiring VS, it's the same process as Visual Studio 2017, which is using the Visual Studio installer, which is like a separate application. You download that bootstrapper, and then you select the kinds of workloads that you want for your development. So you might select, for example, C++ desktop, and that's designed for C++ targeting Windows desktop. There's also a Linux workload, which you'll want if you're also interested in targeting Linux. We also have a mobile workload, a gaming workload, and there's lots of workloads for other languages as well, and other frameworks that are available. And that's kind of how you get things set up. And again, you can install multiple instances of the IDE side by side, managing them all from the same Visual Studio installer. Another tool you might want to use as a companion tool to Visual Studio is the Vcpkg cross-platform C++ library manager. So this is something you can actually install on Windows, Mac, and Linux. So if you have a Linux machine that you're targeting, and you can install your dependencies there as well, for example. And it actually has hundreds and hundreds of libraries available in the Vcpkg catalog. Popular third-party open source C++ libraries. It's really, really easy to get started with it, like a matter of minutes, basically. It's like a 2 or 3 step installation process, and then you run Vcpkg integrate install, which essentially makes it work nicely with Visual Studio and Visual Studio Code for that matter, so that then when you're referencing libraries, so if you say #include catch.hpp, let's say, if you're using the catch unit testing framework, it'll just work. You won't need to go in and modify include pass manually and that kind of thing. Visual Studio and Visual Studio Code will just recognize that those work, and they're from Vcpkg. So the next thing here, in terms of configuration, there's a lot of stuff that we've been working on. So we have 2 different project systems, I guess, at this point that are natively supported in Visual Studio, MS Build and CMake. You can also bring your own build system with open folder support. And we have this Vcpkg integration that now works for both MS Build and for CMake projects. And we've done a lot of improvements on the CMake experience. And we have MS Build project templates. We have a CMake project template as well, which I demoed earlier. You even get IntelliSense building, running, and debugging for targeting remote machines, including for Linux. And most recently, we have kind of the WSL integration I was talking about as a great way to get started. In terms of configuring CMake, there's a CMake settings editor, and there's also some error squiggles you get to help you if you're modifying the JSON file that's behind the scenes directly. So that experience is a lot nicer now in Visual Studio 2019. And another thing that we've done is we've been focusing a lot on performance. If we're looking at the time to kind of get your code loaded and for CMake generation to complete on an open folder project running CMake, this is an example tested with LLVM. We're talking about a 2x performance improvement, so you can get started a lot faster. So that's just something you'll get with Visual Studio 2019, specifically in version 16.1 of the IDE, which is the next version coming up. Okay, so the next thing I wanted to talk about is the building stage, the compiling stage of software development. Okay, so you want to have a good compiler. You want to have a compiler that is standards conformant. You want to have a compiler that provides you good security. You want to have a compiler that is performant, and you want a compiler that has a nice suite of tools that you can use as a companion to that to make your life easier, for code analysis, for example. All 4 of those things are things that the MSVC compiler toolset can give you, and for that reason, we believe that MSVC is the best compiler for targeting Windows. We've continued to invest a lot in the compiler in this release, and we actually have a new tool set available in Visual Studio 2019. It's called the V142 tool set. You can also install the V140 and V141 tool sets if you want as well in Visual Studio 2019. But we do recommend trying out the new tool set. Not only is it binary compatible with those older tool sets, and it has a C++17 standard conformer compiler, as long as you're using the permissive minus switch. It also has the most complete C++17 standard library implementation of any C++ build tool right now. And you actually have a chance of previewing in progress C++ language features with a stood C++ latest switch. So I know one of the things our team has been working on recently was like the spaceship operator that's coming in C++ 20. That's like one of those things you can test out. And you also get OpenMP, there's an OpenMP SIMD extension with the OpenMP experimental switch. So that's some of the stuff that's new in the new tool set. There's also performance improvements, both in terms of code runtime, or application runtime, I should say. And then in terms of build throughput, during the linking phase of compilation, you're looking at over a 2x improvement between from the old tool set to the new tool set. So definitely something that you might care about if you have like an application that takes a while to compile. But we recognize, of course, not everyone uses MSVC. There are other C++ compilers out there, and we want to make sure that you have a great experience in Visual Studio, no matter what you're using. And we're happy to announce that we now have Clang LLVM support in Visual Studio 2019. You can actually edit, build, and debug CMake projects with Clang in Visual Studio. We have MS Build support coming soon as well. We have default Clang build configurations available. If you'll recall, when I was doing the demo and I was looking at all those targets that I could pre-select from, there were some Clang ones there. I kind of ignored them in the demo because I was saving them for this part. But yes, those are now something you have available. It is easier than ever to target, to use Clang as part of your development process with Visual Studio. And you can actually install Clang for Windows from the Visual Studio installer, the same way you install the MSVC compiler. There's a checkbox for it. So you have the option of doing that, or you can bring your own Clang installation, and that should work just fine as well. So that's something that's new. All right, so with that said, I will pass it on to Nick, who will go into a more in-depth demo with a larger code base.
Awesome. Thank you, Augustin. Sounds like this mic is working, so we're good to go. I'll switch over to my desktop. All right. So I'm going to be showing you some new productivity features to Visual Studio 2019. And to do that, I'm going to use the Roller Coaster Tycoon code base, which is that screenshot that you saw just before this. And I'm using that code base because it's a great example of an open source cross-platform game, and it uses CMake. And since this is a cross-platform talk and we recommend using CMake, it's a great thing to look at first. So you'll notice over here on the right, I'm in open folder mode. I was able to open up this code, no problem. And if I go into CMake settings JSON, I can see here's that UI that Augustin showed you before. And you can see I've actually already got a Linux debug configuration set up in here. But I do want to call out one thing. So like Augustin talked about Vcpkg. I already set up Vcpkg. I did the bootstrapping process on Windows and on Linux before this. And so I want to show you just in this output window. If I look here, I can see it says found and using Vcpkg toolchain file, and it's coming from my C drive here on Windows, and that's because I'm in this Windows configuration. So I actually don't even need to type anything in this toolchain file because Visual Studio automatically detected that I have Vcpkg on this machine, and it's found it and is using it for me, which is great for Windows, but I said I also have Vcpkg on Linux, so ideally, it would work the same there. And to set this Linux configuration up, I used the connection manager, which Augustin showed you. So I actually have an SSH connection going out to a remote Linux machine. So let's see in the output here. All right, so here, this time it says it's using this Vcpkg toolchain file, but this time it's coming from my home directory from my Linux machine. So all that's great. And just to show you again, there's actually a pretty nifty link right here. So I can actually click and go right into the connection manager. And you can see I'm not lying. I do have that connection set up to my Linux remote machine. And just a little refresher about that remote connection. That's actually pulling headers over from my remote Linux machine into Windows so that I can get a super high fidelity IntelliSense experience within my Windows environment, even though I'm targeting Linux. And when I build, it's actually going to copy those files over and do the build in that remote environment. So let's go ahead and see what that looks like. I'm in my Linux configuration. Let's exit out of that there and start this up. So in the output window, you can see it's using rsync. So I did install rsync on my Linux machine. That makes this process a little bit faster. And so what it's doing is copying the files over. And I'll open up my VM here so we can actually see it. So here's my Linux remote machine. I'm using Hyper-V. It's a nice VM tool to easily create a Linux VM. And what we should see is the game OpenRCT, which is Roller Coaster Tycoon is what that stands for, has opened up in here. And it looks like we actually hit a breakpoint over here. So what you're seeing now is actually remote debugging. So I'm in Windows on Visual Studio, and I've hit a breakpoint in Windows for a process that was running in Linux. So that's pretty sweet. And you can see I've also got this autos locals window here. I can see things like my call stack. So I'm getting some great debugging features in Visual Studio, even though I'm targeting Linux. And this is a CMake project as well. But for now, let's get back to the game. Let's remove that breakpoint and click Continue. So here's Roller Coaster Tycoon. Some of you may have played this game before. I know I definitely have. I'm going to go into this roller coaster called Electric Fields. I have no idea why it's called Electric Fields. This is a little suspect, but it sounds like a good park to me. So let's zoom in here so we can see. All right, so you can see we've got people leaving and entering the park. I'm at the park entrance right now. I'm going to go ahead and assume everyone going to the park is probably pretty stoked to go. Who wouldn't be excited to go to Electric Fields? Well, actually, let's see. Let's click on someone who's going there. Oh, all right, so Tamsin, if we look at his face there, he's actually about to throw up. He's got this red nausea bar that's at full throttle, so it's probably just a fluke, though. Let's choose a different guest who's entering the park. This person, how about Hazel? Oh, actually, Hazel's also about to throw up. Raphael, all right, Raphael's also not doing too hot. All right, so something's clearly wrong here. Either there's a zombie apocalypse, or I've done something with the nausea levels, and people are just throwing up all over the place. So let's try to figure out what's going on. So I'll exit that debugging session, and luckily, one thing I do know is that Roller Coaster Tycoon is very hip code base, so they actually refer to their people as peeps. So I'm going to assume that I made some sort of mistake in the peep file. So if I go into this Git, this Team Explorer right here, this is the Git integration, which has been in Visual Studio for a while. I'm going to look at the changes, see if I must have changed something recently. And here's this peep.cpp file. So I'm going to go ahead and click that to go into the diff view and figure out if I can see what's, all right, here we go. So nausea used to be a value of 0. Makes sense. That would be some healthy guests. But at some point, I changed it to be equal to this macro called peep initial nausea. I have no idea what that value is. It's hidden behind this macro, but actually, if I hover over that, I can actually see the macro expansion in the quick info, and it's telling me that that's now at a level of 200. So that'll explain the whole zombie situation we got going on. So let's go ahead and fix that. So I'm going to go to definition on this, and it takes me to this peep.h file where you can actually see there's other macros in here that define things like the peep's happiness, their energy level, but I'm interested in this one, this nausea level, which should be 0, not 200. All right, so not sure what that just did, but we are back in a debugging session. Let's exit out of that. Okay, go back to peep.h. All right, so change that to 0. And if you have some good vision, you might be able to see that there's 3 dots under this macro here. And that's actually Visual Studio telling me that there's a suggestion. So what it's saying is, hey, this macro can be converted to a const expr. And so if I just click on this screwdriver here, there's a quick fix right here so that I can actually click on that, and it'll show me a preview of what that change will look like if I decide to actually turn that macro into a constant expression. I can see here's what that would look like. But I actually don't want to do that right now. But if I had decided to do that, I do want to show one other new feature of Visual Studio 2019, and that's this, we have Git stash support. So if I wanted to stash my changes, I can actually do that now in Visual Studio 2019. But that's enough of Linux targeting right now. I want to take this opportunity to switch back into my Windows configuration. I'll switch my target. Okay. So I want to show you some debugging here targeting Windows. We looked at Linux. We were able to do a remote debugging session. But now let's look at how this works for Windows. So first, I'm going to need to set a breakpoint. I know I want to set that breakpoint in a file called game.cpp. And I could sift through the right here. And actually, while we're looking at the Solution Explorer, since this is a CMake project, let's go ahead and change that to CMake targets view, which is a more target-centric view of my code. But rather than looking through here for the CPP file I want to find, since I already know the name of it, I'm actually going to use Control-T, which is go to all. It opens up this search menu up in that top right. It's one of my favorite features. It's been in Visual Studio for a while. And actually, you can search for pretty much anything here. And if you type a question mark, you you can see what sort of filtering you can do in here. So actually, if I type in F, that'll limit my search to just files. M will limit to members, that # for symbols. But I'm looking for a file, so I'll type F, and then game, there it is, game.cpp. It'll take me right there. And then I want to set a breakpoint on line 180, so Control-G lets me look for line numbers, and I can just type in 180. It takes me to this spot in my code where I can click in the margin here, set a breakpoint, or I could have clicked F9. So let's go ahead and start that debugging session now on the Windows side of things. And actually, one thing I want to call out, you probably noticed that there's a lot of colorization in here. That's because I actually went in and changed the semantic colorization of my code, which is something that you've been able to do in Visual Studio for a while, but not a lot of people know about it. But I'm going to explain those color choices right after this debugging session. So you can see the game's trying to load up here, and I've got that breakpoint set in the same spot that I had when I was targeting Linux. It's on the update palette effects. So right when this game is about to load up those graphics, we should hit that breakpoint. If I had music, if I had sound turned on, you could actually hear the theme park music playing at that point. But I'm tired of hearing that music, so we turned the sound off. All right, so I hit the breakpoint. And right now, I'm going to show you how we can step through some of this code and show you some new debugging features of Visual Studio 2019. So using F11, I'm going to step into this object entry get chunk function. So there we are, and now I'm going to use F10 to start stepping through this code. Normal debugging session. You can see I've got all sorts of memory, process memory, and memory usage things on the right there. I've got the autos, locals, watch window down low. But as I'm stepping, you can see I'm actually stuck in this for loop, which I have no idea how many times I'm going to have to step through that thing. Who knows how many times. So I'd rather just skip over it, because in this debugging session, I'm not really concerned with that for loop. I'd rather just execute all the way through it. So what some of you may do in this case is perhaps put a breakpoint over here on line 176, then click continue. It'll run all the way through that for loop, and then you can disable the breakpoint. But that's a lot of clicking. What I'd recommend doing is actually just hover over that line of code there, and then a green little play button appears. And this is run to click, and it's been in Visual Studio since VS 2017. And if I just click that, it'll execute through that for loop for me all the way to this next line of code, which is exactly what I want. I don't have to worry about setting breakpoints, disabling breakpoints, clicking continue, all that mess. So that's run to click. I'm going to continue to step with F11. You can see I've got a string here that says hello build 2019. And then in this next line, I'm appending you rock to that. So if I were to step into this, and just so you all know I actually am stepping into, I'll use the actual UI button. But before I click that, what you may have run into in the past is that you're stepping into your debugging, and then all of a sudden you step into the STL because of something like this. And then you're deep in the inner workings of the STL. Who knows how many times you have to step through there. You don't really care about that code. You're trying to debug your own code. And that's why in Visual Studio 2019, we have a feature called Just My Code Debugging, which now is supported in CMake. This is a CMake project, and it's on by default. So when I click Step Into here, boom, I just go to my next line of code. I didn't step into that append function. It should save you a lot of time debugging, and you'll only debug the code that you care about. But let's go ahead and just keep on keeping on. Step through here a little bit more, and you can see I've got some values down in this window, the locals window right down here, that are changing as I step, as usual. And so I actually just stepped a little bit too far. So I'm going to have to exit out of this debug session, start it back up, rapid fire step all the way till I get back to that line without overshooting it. But actually, I don't have to do that, because in Visual Studio 2017, we introduced historical debugging, so I can actually step backwards now. This button up in the top, if I just click that, now I'm in a historical debugging session. I didn't have to restart because I accidentally overshot what I was looking at. So now if we watch this locals window down here as I step back, let's try to get back to the string. Yeah, so here we got hello build 2019, you rock. And if I go back to before that append happened, you can see that value is actually going to change to a snapshot in time of before I actually appended. So I didn't have to worry about restarting my debugging session thanks to historical debugging. But while we're looking down at this window here, I do want to point out a feature that's new to Visual Studio 2019, and that's the ability to search this. So if I know a value that I'm looking for, I can search by value. For example, if I type hello, it takes me to that hello build line. But I can also search by name. So if I'm looking for a result, for example, boom, it takes me right to result. And that's a feature that's new in Visual Studio 2019 and can definitely come in handy if you've got a lot of different names and values in this window right here. Finally, the last feature I want to call out regarding debugging before I move into some code editing productivity tips is that Visual Studio 2019 now has an out-of-process 64-bit debugger. So you won't run into any memory crashes or anything like that. And that's a feature that a lot of people have been asking for, and now it's finally 64-bit out-of-process debugger. So with that said, we can exit out of the debugging session. All right. And let's go back into that original game CPP file I was in. So I was talking about my colorization. How many of you have actually changed the colorization of your editor? Just by show of hands. All right. So perfect. I can teach you all something today. Basically, if you want to change your own colors, you can do that through some menu system. I actually don't remember what menu it came from, but Visual Studio 2019 has this new and improved search menu up here. So if I just type font, I can just click this first link right here, change fonts, and that's where you can change whatever semantic colorization you want. It'll take you right to that menu. So I could actually limit this search to just menus or components or templates, but I'm obviously looking for a menu now, and so if I click that, that's exactly where you go, and you can change the colorization however you want. I've changed mine to give me a better sense of the scope of what I'm dealing with. So for example, I know everything in pink is global scope. Bold pink is a global method. And then the non-bolded pink is a global variable. I know that this navy color is a local variable. I know the brown is a field, et cetera, et cetera. So just with my colorization, I have a great sense of the scope of the different constructs that I'm looking at. But you've been able to do that in previous Visual Studios. What makes Visual Studio 2019 awesome is that we actually extend this colorization to Quick Info tooltips. So if I hover over something here, I'm actually getting full colorization in Quick Info that respects my semantic colorization. Whereas previously, this tooltip used to be just all black. And another new thing about Quick Info in 2019, see this closing brace here? I have no idea what that if statement is that it's in the opening brace. I could scroll all the way up, but I can actually just hover over it, and we have Quick Info on that closing brace, and it shows me exactly what that if statement is. So I don't have to scroll all the way up to see what this brace is associated with. And then, of course, a feature that's been in Visual Studio for a while is these gray structure guidelines that you can see connecting those braces. And if I hover over that, I can see the structure visualizer. So I can actually see the total complete nesting, but in Visual Studio 2019, this again is colorized. So I can see the full nesting of ifs and for loops that I might be within, which can be super handy if you're deeply nested. All right, that's enough colorization. Let's actually look a little bit more at editing. So I'm going to go use Control-T again, which is that shortcut that not many people know about, but you should definitely remember after this talk, because it's a lifesaver. So Control-T is go to all, and then I'm going to limit my search to files again with F, and look for a file called filescanner.cpp. So now that I'm in here, if I use Control-G, which is go to line, I'll go to line 214 or so. Yeah, here we go. So in this code, I've got a vector called patterns. It's right here. If I hover over it, it tells me, all right, here's a vector. And you can see I've used pushback on it. Well, before I show this next feature, how many of you have heard of IntelliCode? Not IntelliSense, but IntelliCode. All right, quite a few of you. Sweet. For those of you who don't know, IntelliCode is basically a smarter completion, and what it is a machine-learned algorithm that was trained over thousands of GitHub repos, and based on all those repositories, it's able to take the context of your code and give you a better suggestion of what you might actually want to type in that context. So in this case, I've used pushback. So if I type patterns dot, you'll see there's some starred suggestions here up at the top, and those are coming from IntelliCode. And it's saying, all right, if you use pushback once on this vector, you might want to push back something else on there. Or based on this situation, people might want to check the size. You know, you've added something to the vector. Let's see what the size is. Well, I'm going to take it up on its offer to use pushback. And actually, so now that I've made my first edit in this code base, you'll see Visual Studio is letting me know, hey, we found a Clang format file in here. And we're just going to go ahead and automatically use this for all your code formatting. Does that sound cool to you, dude? I'm like, yeah, sounds cool to me. I'm going to click OK. And then, boom, here we are. And actually, there's a red squiggle here now. Let's see what this error is. No instance of overloaded function matches the argument list. All right, it's a pretty lengthy error message here. And some of you may know what this means. But if you're new to Visual Studio, you might not be used to that error yet. But luckily, in Visual Studio 2019, we've added this Search Online button directly into Quick Info. So if I click on that, and assuming that my internet works, all right, sweet. So I've linked that button up to work with Bing. And so now that took me to a Bing search with that error, and I can see, all right, here's a Stack Overflow issue that sounds related, and I can start investigating that error and see how I can fix that. So that's a feature that's new to Visual Studio 2019. I'm going to go ahead and just delete that line. All right, so obviously patterns is a vector. So as all of you probably know, this file probably includes just like a #include vector up at the top, right, so that you can actually use vector with no issues. But let's just go ahead and verify that. Let's use the scroll map over on the scroll bar to find our includes. There they are. Yeah, so you can see I'm using vector. I'll click on that just to show you here. So #include vector makes sense. But it's not always easy to know what you need to include, right? For example, maybe you have some class that you've written, and you're trying to use that class, and you get that class is undefined error message, and you can't remember what header you put it in. Well, Visual Studio 2019 can help you with that as well. For example, here's #include stack. If I were to just delete that to pretend like I had forgotten to include stack, let's see how Visual Studio can help. Well, one new thing in 2019 is this new document health indicator. So I can see that I now have 11 errors in this file, probably because I deleted the include stack. But let's just go ahead and dig into one of these. So here's an error message. If I click on it, it'll take me right there, and you'll see that there's a light bulb in the margin there. Well, that's letting me know that there's a quick action here to address this error. So if I go here, you can see add #include stack. So that's a new quick fix in Visual Studio 2019. It's add missing #include. So it knew that I was missing stack. I've added it. You can see all of my errors have gone away. The document health indicator is telling me 0. And if I look back up at the top, stack was added right there. So that's an awesome new feature of Visual Studio 2019. Hopefully it comes in handy. And one last thing I want to show regarding #includes that's new to 2019 is if I want to actually go to one of these documents, I could right-click and say go to document right here. But in 2019, we've actually repurposed, or actually multi-purposed, F12 to not only be go to definition, but now it's also go to document. So if I just click F12 on that, boom, it takes me right to this file scanner.h file. So hopefully that works well with your muscle memory when you're just using go to definition. Now you can also use it to actually go to a file, go to document is what we're calling that. So this file scanner file it's pretty interesting, but I want to go to something a little bit spicier, something a little cryptography related. So let's go to this thing called there it is, crypt open SSL. And if I scroll down here, we can see on line 40, I've got this open SSL hash algorithm. It's a template, and it's got type name tbase. Well, if I click inside of this template, there's this UI element that was introduced in VS 2017, and it's called the template bar. Now, this thing is expandable and collapsible, and it allows you to provide sample arguments to get IntelliSense within the template body. Because Visual Studio doesn't know what type tbase is, so how's it supposed to give you IntelliSense in here, right? So in 2017, we give you the ability to click this pencil icon right here, and you can actually manually type, hey, I want tbase to be rectangle, I want tbase to be int, or whatever. But that was a manual process, and based on your all's feedback, in Visual Studio 2019, we've iterated a few times, and we've added this option here, add all existing instantiations. So what this is going to do is when I click that, it's basically doing a find all references call, and it's actually locating places I've used this template, this OpenSSL hash template, in my code base, and it tells me what file, what line number it came from, and then over here in the right column, it shows me tbase equals SHA-1, tbase equals SHA-256. So it's showing me actual instantiations in my code base so that I can use those in the template bar, and that template bar is now populated with those options. So I didn't have to manually type anything. And so now if I click one of these, SHA-1 for example, and scroll over, and I hover over something that's using tbase like this, now it says crypt SHA-1 algorithm. So I'm getting IntelliSense as if tbase were of type SHA-1, and just to prove my point, if I switch to 256 like that, and hover over it, now it says SHA-256. So in Quick Info, I'm getting IntelliSense for my template. So that should help a lot when you're debugging, because even when, let's say I want to add new code, if I do something like tbase, and then these two colons, now I'm getting memberless completion as if it were of type SHA-256 algorithm, which you can see right here, this clear method. So if you're debugging a template, this is a great way to actually use actual instantiations in your code base without having to manually provide those sample arguments. The last thing I want to show regarding productivity features in Visual Studio 2019 is that code analysis now runs in the background. So you may have noticed earlier that I have one little warning here in this file. And if I double-click on that, it'll take me there, and you'll see that there's a green squiggle under result. If I hover that, it says variable result is uninitialized, always initialize an object. But luckily, there's a light bulb right here, and it shows a preview of that fix in that preview pane. And if I click that, it'll go ahead and initialize it for me. The green squiggle goes away, and the warning goes away. And now the document health indicator is saying, hey, no issues found. That's everything I want to show with Visual Studio 2019 productivity features. I know that that was a lot to cover, so I actually have a couple slides just to recap. Hopefully this thing still is working. Just to recap what we saw. So some of the main overarching ideas is that you don't need to compile all your third-party libraries by hand. You can just get them through Vcpkg, which is what I did. At the very start, I told you that I used that Vcpkg bootstrap process that Augustin mentioned in order to get my dependencies on Linux and Windows, and then Visual Studio was able to automatically detect those Vcpkg installations and use that toolchain file for me with no extra work on my part. Then you can also use these 2019 features that I showed you, whether you're targeting Windows or Linux, and then MS-Build or CMake. Like everything that I showed you was with a CMake project, right? And then finally, you can use the rich debugging features on Windows even while you're targeting Linux, which is what I showed at the very start of that demo. But I did show a lot of different productivity features related to writing code, so I wanted to just put a bullet list. And this list is designed for you to take a photo of it if you want, and then you can look up blog posts related to them or ask questions directly to me about any of these that sparked your interest. On the left, I have some features I wanted to call out to people who may be completely new to Visual Studio. These are sort of like the fundamental features of writing code in Visual Studio. I showed a couple of these, like that last one there is platform-specific IntelliSense. Oh, actually, I'm not sure if I did show that. But platform-specific IntelliSense is purple squiggles that will appear in your editor to let you know if, hey, something might have worked in your Windows configuration, but in your Linux configuration, which I know about, it's going to give you a purple squiggle, which lets you know that in your Linux debug configuration, that would actually cause an error. And if you're interested in platform-specific IntelliSense, there are blog posts about it. I meant to show it. But lastly, on the right-hand side of the column is things that are actually completely new to Visual Studio 2019. I showed most of these. I didn't show, for example, live share, which is the third bullet there. But there's plenty of talk about live share at build. And the main thing to know is that C++ is supported with live share. Now, if I go to the next slide, here's debugging. So new to Visual Studio was the 64-bit debugger, just my code support for CMake, so that allowed us to skip over the STL while we were debugging, and then finally the ability to search in the watch window. But then on the left-hand side, I did show that second bullet, that run-to-click thing. So when you hover over a line, you can click that green arrow. And then there's a few other things in there, like conditional breakpoints that you should be aware of if you're new to Visual Studio. I'll give you 1 second for a few people taking photos. All right. Now, the last thing we looked at was background code analysis. That's that first bullet point there on Visual Studio 2019. And that now runs by default in the background, and that gives you those green squiggles. And there's a few other things that I didn't have time to show, but that's like there's some new core checker rules, some new concurrency check rules, and there's also ASAN support for Linux now in Visual Studio 2019. And then for those of you who maybe are completely new to Visual Studio, on the left-hand side, just be aware that we do support Google Test and Boost Test. We have blog posts about these things, and they work very nicely with our Test Explorer in Visual Studio. It's totally integrated. The last thing is the source control. So I showed you the Git integration in my first fix where we saw that diff view. That's been in Visual Studio for a while. But new to Visual Studio is Git stash support, which is that drop-down option that I showed in the Team Explorer window on the right-hand pane. And then I also encourage you to look at the pull request extension, which you can get at aka.ms/pull-request-for-vs. That's everything for Visual Studio. But now Augustin is actually going to jump in and talk a little bit about Visual Studio Code.
All right. Thanks, Nick. There was a lot of different productivity features there in that demo. So yeah, it's great to see the state of where Visual Studio is today and just how many different options you have to really save you time as a developer. And the nice thing about it, of course, is one of our emphasis is to make sure that things work across platforms. So we want things to work on Windows and for when you're targeting Linux. So it's kind of cool to see that CMake code base. And seeing that code base that can build both for Windows and Linux, and it has all these nice features that you can take advantage of to stay productive. But let's say you're not, let's say your development machine isn't a Windows machine, so you don't have the option of using Visual Studio. Well, what do? Well, there's Visual Studio Code, actually, and Visual Studio Code is a really, really nice, lightweight code editor. Right now, it's the #1 most used code editor in the world, according to the Stack Overflow developer surveys of the past 2 years, so that's looking pretty good. It certainly has a great C++ experience as well. There's a C extension available that you should definitely get if you want to use Visual Studio Code with C++. That will give you things like IntelliSense and the ability to debug and some nice code browsing features. Definitely something you should take a look at. And you can get Visual Studio Code on code.visualstudio.com. It is cross-platform, runs on Windows, Mac OS, and Linux. And actually, let's show you a little bit of how Visual Studio works, or Visual Studio Code works, and how easy it is actually to get started with it. So yeah, we're going to switch to a demo here. What I have here is actually a Linux Ubuntu VM, just to prove that this isn't just for Windows. Right? So we've got a little small code base here opened up. Basically, it defines something called a box. It defines a length, width, and a height, and it calculates the volume. Very straightforward. One of the cool things here, so let's say I hover over this box. Let's say I don't really know what this box does. Well, I can see if I hover over it, I can see it's a struct. Yeah, I get some nice syntax colorization there, and it tells me what it is. And it tells me definition of a box object with 3 dimensions. Well, where is that actually coming from? Like, where is that description coming from? Because this is like a custom-defined piece of code, right? So if I right-click it, I can do go to definition, which also works in VS Code, and it'll bring me to the header file and it'll tell me, yeah, this defines a box, and it has 3 dimensions. There's a little comment up here right above it. So a user or a developer-defined comment describing what a box is. So essentially, if you write any code in VS Code and you have the C++ extension installed, that comment that you put above, kind of like where you're declaring the struct or the class or the function or whatever it is that you're defining, that will actually show up when you go and hover over that item anywhere it appears. So if I go to the CPP file, it'll tell me what it is. So it's a nice way of kind of keeping track of what's going on. But OK, so let's say I want to actually get this to build and actually run and debug in Visual Studio Code, which sounds like, well, how would that work? I don't have a CMake project. I don't have an MS Build project. It's not like Visual Studio where it just has all that stuff there. So what can I do? Well, actually, if I set a breakpoint here, I'm going to do that, and then I'll right-click and say build and debug active file. New feature. So what this is going to do is going to ask me, OK, which compiler are you trying to use? I have G++ installed on this Linux machine, so I'll use that. It'll just detect what compilers I have installed and provide me with relevant options based on that. And it will use GDB in this case and actually start a debug session. So you can see I actually paused on that first line. And I'll just switch to my terminal just so you can see what happens. So if I do F10, right, package length 10, width 10, height 10, volume 1,000. In a couple of minutes, I've just gotten this application to build and actually debug in Visual Studio Code. I didn't have to do any special configuration. It just kind of works. And that's the nice thing about that. We focused a lot on the configuration experience for Visual Studio Code. We've gotten a lot of feedback over it. We wanted to make it as easy as possible for you to get started. So you have that nice like single file application. I don't have to do any work. It just kind of does things. So I can see here I actually created a task.json file for me, which defines exactly how everything will work behind the scenes. And I just had to select my compiler, and I'm done. Simple. Now, suppose I had to do some more work here. So, OK, let's say I actually have let's say some other header, some other library that I'm trying to use in this code base. OK, so what do I do? Well, let me see. I think I have it over here. It's like in this folder called volume math or something, in like my documents. OK, so I'm going to say, I'm just going to add a pound include to it. So I'm going to say pound include, and I think it's like volume math / volume.h. Oh, let me fix that. Volume.hvp. OK, well, where is that file? Good question. It's somewhere else. It's not in my VS Code workspace. It's somewhere else. So, and let me just actually make sure that I've got the path here. So yeah, so volume math, volume.hvp. But VS Code doesn't know right now about this documents folder having headers that I'm actually using for my project. So how do I actually configure that so that my IntelliSense will work nicely? Well, I can actually go ahead. I'm going to do Control-Shift-P, opens the command palette, OK, in Visual Studio Code. And if I search for like C++, it'll give me C++ configurations. And you can see there's like an Edit Configurations option. And there is both a UI and a JSON file. So if I did JSON, What this would do is, this is kind of the traditional way of configuring IntelliSense in Visual Studio Code. There's a CCPP properties.json file that I can use, and I can do that in there. If, for example, I went and tried to set the C++ standard, and I said, I want C++ 19, except C++ 19 doesn't exist. Visual Studio Code tells me that, hey, that's not accepted. These are the accepted values you can actually use. OK, sorry about that. Let me change back to C++ 17. C++ 20 isn't standardized yet, so let's not go there. But then I don't actually even have to use this JSON editor at all, because as I saw there was actually a UI option. And this will actually bring up the IntelliSense configuration editor UI, which is kind of a friendlier way of going and configuring all these things. I can change my active configuration. I can set my compiler path. VS Code already knew. By default, GCC gets installed to this place, so I'll just have it there. And it just kind of works out of the box. But I can actually go and I can set my include path right here. So let me see if I can remember where it was. I think it was in, let me see what's a good way to get the paths here. OK, so all right, so anyway, so if I set the include path, I can actually set the include path in here, and I'll add the include path, and then everything, the IntelliSense will basically work, and I'll be able to use the header file and reference it in Visual Studio Code. So that's basically how that works. So if I actually go ahead and, so I'm going to go ahead and switch back to my slides here. Okay. Yep. So, all right, so a few things there. So Visual Studio Code does come with some productivity features you can take advantage of. So you saw go to definition there. We saw if I hover over a box, it tells me the comment that describes what the box does. And I saw that, OK, I can actually get this single file application to just build and start a debugging session, basically just by right-clicking and choosing Build and Debug Active File, which is a nice new feature in Visual Studio Code. And of course, I can use VS Code on Windows, Mac, and Linux. So that's nice. And there's actually quite a lot of features that we've worked on in the past, over the past, I guess just this year alone, really. So just looking at January to May, you can see new functionality in Visual Studio Code. It does have a different release cadence than Visual Studio. I can see I had doc comments for not just hovering, but also for completion and signature help. Improved member function completion. IntelliSense performance has been worked on as well. There's the build and debug active file feature I showed you. There's the configuration settings editor, so I don't have to use the JSON behind the scenes if I don't want to. And it does give me squiggles, though, if I do use that JSON file instead and I make a mistake, like I say C++ 19, and that doesn't make sense. But another thing that was announced for Visual Studio Code was remote development. This was announced, I think, last week. So this is actually available with a C++ extension. It allows you to do things like developing your C++ programs on the same operating system you're actually deploying to, sandboxing your development environment, use runtimes not available on your local OS, access an existing environment from multiple locations, and even debug an application running somewhere else. This is now something that works for Visual Studio Code. If you're interested in learning more about that, we do have a C++ booth here at Build. We recommend you stop by and ask us some questions about it. That's something that's cool. And OK, so we're running short on time here, and I want to make sure we get everything covered. This is basically this is the second last slide I have to kind of summarize what your different options are for development. OK, so the traditional way of doing Visual Studio development, you're on Windows and you're targeting Windows. So you have the Visual Studio IDE. You have Vcpkg, which we recommend for managing your C++ libraries. You can use either CMake or MS-Build. You have a CMake settings editor. You also have MS-Build project properties. We do recommend using MSVC to compile for Windows. And you can use all the Visual Studio features available. There are test adapters for Google Test and Boost Test. There's code analysis tools that run automatically in the background for your projects in Visual Studio 2019. And there's source control integration in VS as well. If you're cross-platform targeting both Windows and Linux, we recommend having a CMake project. You can also use MS-Build. We do have MS-Build project templates for targeting cross-platform, but CMake is kind of the more popular choice these days for cross-platform work. You can use WSL to get yourself started really easily. You can use different compilers, so you can use MSVC, for example, for Windows. You can use Clang or GCC for Linux. You can do stuff like that and mix and match with whatever you happen to need. And if your development machine isn't even Windows, you can use VS Code and all the tools we showed there on that. And lastly, we recommend if you want to keep up with the news, devblogs.microsoft.com/cppblog. That's our blog. You should check it out. That's where we post all our announcements. And
I just want to hijack this real quick.
sorry about that.
So I didn't get to show platform-specific IntelliSense because I forgot, but it would kill me if I didn't show. So if I do like include, I'm in my Windows configuration right now, so I'm just typing away, and I include something like windows.h. You can see that there's a purple squiggle here, which is what I was trying to explain, but it's much better if you actually see it. And what this is doing is if I hover over it, it says, hey, your Linux debug configuration can't open windows.h. So even though I'm in my Windows config right now, Visual Studio knows that I have this Linux configuration. So if I'm heads down in my Windows development, Visual Studio is giving me that constant reminder like, hey, make sure that you're thinking about your cross-platform stuff because you have a Linux configuration in there. So if you want to use windows.h, what this project actually does is they're putting it in an if-def here with Win32. But that was platform-specific IntelliSense. That's what those purple squiggles are. I just wanted to show that real quick because we are like out of time now. So.
Okay. And with that awesome feature showcase there, that's the end of our session. Check out our booth at Build if you want to follow up with us. There's also a talk at 1 on remote development of Visual Studio and rich code navigation. You should check it out. There's a specific booth it's at. And yep, that's it.
Thank you all so much.